Hello everyone. In this video we'll be discussing about force versus time graph and what is the meaning of the graph. So if there is a collision and if we can able to record the force versus time graph of a collision, the graph is gonna look like this, okay? So basically you can say that this is a graph when you kick the soccer ball, or this is a graph when a car hits a wall, any collision. So if you have a force versus time graph, and in this graph it's going to have a maximum force, and we can say that there is a average force, because force is varying here. That's why we can mention about an average force here. When we look at when we do dimensional analysis, so when you divide, we cannot get slope, but there is an area here. We can get the area under the line. So area means multiplication, newtons times second. So when we look at the area of the graph, we get a unit of newtons times second, and that is the unit of impulse. So the area of the force versus time graph will give us impulse. And one more time, let's write the impulse equals force average times time. Okay, so now let's discuss about, so right now there is a relationship between force and time, and this relationship is inverse relationship. So if the direction of the collision can be increased, like if we change the time here, then the force will be decreased. Okay, so right now when this is the here, that is the interaction time between interaction time. Now when we increase the time, I'm going to try to draw another graph here. When we increase the time, the graph will look like this. So the area should be same in the first case, but when we increase the time, then what happens? The maximum force is decreased, right? Okay, there is a lot of real life application about that, and I would like to show you one of them. That there are two eggs, and there are initially at rest. Okay, and they will be dropped at the same height, and one of them will be dropped to the let me draw it with different colors. So let's draw it with different colors. It's gonna drop on a pillow. Okay, let's say that there is a pillow here. Okay, so initially they have the same velocity, which is initial velocity 0. They drop from rest, and they dropped at the same time, and they are same size A. Okay, so when they reach at the bottom, in the both case, they will have a maybe my drawing shows that there is a height differences, but let's assume that you are using a thin pillow, and relative to height, this is a small height. Okay, so just before they hit the ground, the both eggs will have the same velocity. Okay, so which means I'm gonna look at this just before it hits the ground, and just after it hits the ground. So just before the eggs hit the ground, just before the egg hits the ground, or like tile floor and pillow, they're gonna have the same velocity. Okay, what's kind of the final velocity? The final velocity will be 0. It's gonna stop here and it's gonna stop here. Okay, so what do we expect? are both of them will land safely, or one of them will damage? Actually, if you do that experiment, you know that the one that goes on the tile is gonna crack. Okay, so what is the reason for it? How can we explain that? Okay, so here again, just before it hits the ground and after it hits the ground, the velocity before it hits the ground and after it hits the ground is same both cases. Okay, so delta p and delta p for this case will be same. Okay, change in momentum, mass are same, final velocity minus initial velocity will be same, delta p will be same. Then what is differences? Okay, so this one, the interaction time will be larger. Okay, so let me write the main equations here. So remember, delta p was equals f times average velocity times delta t, and mass times delta v will equals f average times delta t. Okay, here left side of the equation are equals delta p and delta p. So what is the difference here? Here the difference is force is here, average force or maximum force will be much larger here, but here average force will be smaller, but the time increased. Okay, maybe I could make it a little larger. Because of that, this one will experience more force and it gets